Hello, and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 2092, Find All People with Secret. Before we get into this problem, I just want to ask you to kindly subscribe to the channel. If you're getting value out of these questions, especially me solving these hard Google questions, then please subscribe. It takes only a second and it doesn't cost you a thing. So if you want to see more content like this, please subscribe because you guys are the motivation for me to keep making these videos. Anyway, let's read the question prompt. It's quite a mouthful. You are given an integer n, indicating that there are n people numbered from 0 to n minus 1. You are also given a 0-indexed 2D integer array meetings where meetings of I equals to x of I, yi, and time of I, indicating that person x of I and person y of I have a meeting at time of I. A person may attend multiple meetings at the same time. Finally, you are given an integer first person. Person 0 has a secret and initially shares the secret with first person at time 0. This secret is shared every time a meeting takes place with a person that has the secret. More formally, for every meeting, if a person x of I has a secret at time of I, they will share the secret with person y of I and vice versa. The secrets are shared instantaneously. That is, a person may receive the secret and share it with the other in the meeting within the same time frame. Return a list of all the people that have the secret after all the meetings have taken place. You may return the answer in any order. Okay, now that we read that question prompt, let's look at an example and think about how we might want to solve this. It's actually a lot easier than you may think, and the solution is really not that bad. So let's go through an example. Okay, let's go through one of the examples. Let's say that we're given that there are n equals 6, so that means that there's 6 people, and we have these 3 meetings, which means that person 1 meets with person 2 at time 5, person 2 meets with person 3 at time 8, person 1 meets with person 5 at time 10, and we know that the first person to get the secret is the 1. And remember that the secret starts with person 0. So let's think about who's seen the secret so far. We'll call this, S for who has the secret. So we know that from the problem description, person 0 starts with the secret, right? And they're going to share it with this first person at time t equals 0. So that means, at the beginning, person 0 and 1 are going to have the secret. Okay, now let's go through the meetings. So the first meeting to happen is between 1 and 2 at, t equals 5. So because person 1 has the secret, right? They have the secret because it was shared with them originally. In this meeting, they share it with person 2. So now person 2 has this secret. So they're going to get it. And now we move on to the next meeting. And we go to the next meeting, which is between 2 and 3 at time t equals 8. And basically, because 2 has the secret, it was shared with them at time 5. And now it's time 8, so this is a future meeting. That means that person 3 is also going to get the secret. Then the last meeting to happen is going to be between 1 and 5 at time 10, right? So because 1 has the secret, they're going to share it with 5, and therefore, this is how we get our answer. But this is quite simple. Why? Well, for one, our input here happens chronologically, which we're not guaranteed in the real problem. So we'll have to account for that because we need our meetings to happen chronologically, right? You don't want to have to deal with meetings that, you process something, but then this meeting happened before. How do you time travel? We can't do that. We have to process things linearly, right? And also, this is a bad example because there's no meetings that occur at the same time, right? What if there was another meeting, because the problem description told us that a person can have multiple meetings at the same time. So what if 2 had a meeting with someone, say like 4, and then also like 4 had a meeting with someone, person 8? Then we would have to chain these and account for that. So this isn't the greatest example, and Leetcode is basically trying to, make it seem a lot simpler than it is, which it's not. So we need to account for those things. And let me just erase what I can here, and basically we're going to go through how we want to solve this problem. So remember that the first thing I told you is that we can't time travel. I mean, that would be great. I would just go back in time and buy stocks when they were worth pennies and I'd be a billionaire and I wouldn't even be making these videos, but that's another story. So the first thing that we want to do is actually sort our meetings. So sort on start time. Because obviously we can't travel backwards and we want to process things chronologically. So we're going to sort on our start time. And we also need to know all the meetings that happen at a certain start time. So that way we can, if we need to chain meetings together, we know how to process them and how many meetings are taking place. So we need a map. So we're going to build a map between the start time of a meeting and then a list containing all the people that are meeting there. So it could be like, person 1 and 2, it could be person, 2 and 4, yada, yada, yada. So basically all the meetings that are taking place at that time once we've, sorted it. So that's the second thing that we need to do. And then the third thing that we need to do is actually perform a breadth first search. And we can actually do this with a depth first search as well. It doesn't really matter. I prefer to use a breadth first search because obviously you don't have the issue of potentially having Stack Overflow when you do a recursion on a very large graph here. So I will just use breadth first search here, but you could use DFS if you're more comfortable with it. The solution I'm going to give you is with BFS. So if you want to do it with DFS, you'll have to adapt it yourself, but it probably shouldn't be too bad. So how are we going to do the BFS? Well, let's think about it. We want to go, we have our sorted dictionary here, right? And we sorted it so we could process things in time. And when we actually build this map, because we're going to go through the meetings in chronological order, now that we've sorted them, Python has this nice structure that dictionaries, I believe after Python 3.6, are actually under the hood ordered dictionaries. So we will get the elements in the order that we inserted them. If you're not doing this in Python, you're going to want to make sure that whatever data structure you use, you want to make sure it's an ordered dictionary. And the reason we need to do this is, again, we need to proceed in chronological order, and we can't time travel. So it has to be ordered based on the meeting time. And again, Python has the nice property that all dictionaries, I think it was after 3.6, are by default ordered dictionaries. So because we insert them in the chronological order, they're going to stay in chronological order when we actually go through the values. So the reason that we want to do this is for every time, right, we're going to loop over the start time and all the meetings that are happening at that time. And we need to build a graph now. So we're going to say, okay, so let's say person 1 has a meeting with person 2. They also have a meeting with person 5, who has a meeting with person 7, who has a meeting with person 9, and let's say 5 also has, you can't see that, sorry, it's outside of the bounds of my drawing. And this guy has a meeting with person 9 and maybe like 4 here or something like that. So if person 1 has the secret, right, what we want to do is basically we want to traverse this graph, and because secrets can be shared instantaneously and at the same time, so as soon as 1 has a meeting with 2, 2 has it, and then 2 can also have a meeting at the same time as per the question prompt. A person can have 2 meetings at once. It's weird. Don't think about it in like a real world scenario. This is just the problem. So 1 gets it, which means 2 gets it, 9 gets it, and then also 4 gets it, and then 5, and then obviously we just go through the tree. So that's why we're doing a BFS. But we need to build this graph every single time we iterate over each key value pair in our dictionary, because the graph is going to change each time. And what we want to do is we want to make sure that, one, we keep track of a scene set so we don't get caught in some sort of like infinite cycle. And also we need to keep track of who has the secret, right? And remember, we were keeping that set to indicate who has the secret, because if someone already has a secret in our graph, basically we don't want to process them anymore because they'll already have shared it. So we want to make sure that we don't accidentally, re-add people, because we could screw up and end up processing more than we need to, because once someone has a secret, we don't have to add it back to our queue. So remember, in the beginning, person 0 always starts with a secret, and then whoever first person is, and then as we do that, graph traversal with the BFS, we're basically going to traverse all the meetings that are happening based on who has the secret. So for example, like let's do a better example. So like 1 and 2, and then maybe 0 and 5 and 7. So basically what we want to do is we want to iterate over all the people who have the secret and then check all of their meetings in a BFS manner. So we're going to start, okay, we see that 1 has the secret. So we're going to go to 1, which means that 2 also now has the secret. And then 0 has it, which means that we're going to traverse the entire thing for all the people who have the secret at the current time that, when we're processing a pair here. And if this doesn't make sense, don't worry. I think that once we actually go to the code, it's going to be a lot clearer. There's a lot to kind of take in here information-wise, and I think it's going to be better if at this point I just stop throwing information at you and we just go over to the code editor and you can see it line by line and I can explain it there. I think it'll be a lot more clear. So I'm going to stop rambling. Let's go to the code editor. It's really not that bad. I'll see you there. Okay, we are in the code editor. It's time to write the code. I promise it's not that complicated. It seems like it's a hard question. It really isn't. So remember that the first thing that we need to do is sort our meetings based on the time that they start. And we need this because, again, we can't time travel. We don't want to be processing meetings that happened after meetings that we've already processed. We want to make sure that we process them chronologically because that's really how time goes, and we can't time travel. So we're going to say meetings.sort. And remember that meetings takes the form of person 1, person 2, and then the time they're meeting. So we need to sort on that second index in the actual list. So we're going to say key is going to be lambda x, where x is that meeting, and then we're going to sort on the second index, which is our meeting time. Now, remember, we want to make a mapping between all the meeting times and all the people that are meeting at that time. So we're going to say meeting dict is going to be collections.defaultDict list. So basically we're going to store for each time a list of all the people who are meeting then, and we're going to store that as like a tuple, and we're going to say for person 1, person 2 time in meetings, right? We're going to say, okay, so meeting dictionary for that time, we're going to append to the list for that key. We're going to add the meeting between person 1 and person 2. So we're going to get a list of all the people who are meeting at a given time. Cool. So now we've built that dictionary. And remember, we need to keep track of who has the secret. So we're going to say has secret. And this is going to be a set because we don't want to accidentally have duplicates. So in the beginning, this is not 0, 1. This is going to be 0 and then first person, because remember, person 0 has the secret and then it shares it with first person at time 0. So that's why we start with 0 and first person as the people who have the secret. Now remember that we need to go through all the times chronologically. And again, remember that in Python, all of our dictionaries, if you're using Python 3, actually you should not be using Python 2 because it's been deprecated. And if you still are, then hello, it's 2022, use Python 3. Remember that when we insert into dictionaries after, I think, Python 3.6, basically it's going to be an ordered dictionary. So we can guarantee that the time that we insert is actually going to be the time that we're going to get it back when we actually loop through the key value pairs. And because our meetings are in the order already, because we sorted them in the beginning, we won't have any issues with getting meeting times out of order. So we're going to say for time, we're going to say in meeting dictionary .items. So we need to parse through all of those key value pairs. We're going to say, we need to build a graph, right? So we're going to say collections.defaultDict list. So we basically need to build a graph of all the people that are meeting at a certain time so we can traverse it with our breadth first search. And remember that we need a scene set because we don't want to be going in an infinite cycle here. So we're going to say for person 1, person 2 in meetings. And remember, meetings is a list of lists where the inside list is the two people that are meeting. So we're going to say, fix my indentation here. We're going to say graph. So person 1 is going to be meeting with person 2. So we make that edge between them. And we're going to say graph of person 2 dot append person 1. So that way we have the reverse edge. And basically, if person 1 is one of the people that has the secret, then we can add it to our scene set. So we can say if person 1 in has secret. So basically, if we already know that this person has the secret, then we don't need to kick off our BFS from them because there's no point, right? So what we want to do, sorry, apologies, I take that back. If the person has the secret, then we need to start our BFS from them because those are the starting points. And basically, we want to start with people who have the secret and then try to reach all the other people that we can at a given time to figure out who also receives the secret. Apologies for that little miswording there. So we're going to say scene.add person 1 to indicate that this is one of the people who has the secret, and we need to kick off our BFS from there. So we're going to say if person 2 in has secret, then we want to say scene.add person 2. Okay, at this point we have built our graph, and like I said, you can do it with either breadth first search or depth first search to figure out who has the secret. It doesn't really matter. What I will say is that DFS, because it's recursive, can overflow if the graph is very, very large, and typically that's not something we want. Because the performance of BFS and DFS is the same, I would strongly urge you to just write it with BFS because you don't have to worry about overflows. Your time and space complexity of the traversal is going to be the exact same, but with DFS you have the potential for overflow, and your interviewer might ding you for that or ask you to implement it in BFS, wasting precious time in the interview. Anyway, let's do the BFS. So we need a queue, so we're going to say collections.deck for our queue data structure. And remember that we want to kick off our search from each of the people who have the secret, right? Which is going to be represented in our scene set because we were populating with the people basically in the graph at that current time who have the secret. So we populate it with scene, and now we just do the BFS. So we're going to say while queue, we're going to say person, we're just going to pop a person from the queue, and we're basically just going to traverse all of their edges and share the secret with them, assuming they don't already have the secret. So we're going to say for neighbor in graph person, we're going to say if that neighbor doesn't already have the secret, so not in has secret, then we want to share the secret with them. So we're going to say has secret dot add neighbor, and we want to add that neighbor to the queue so we can pass on the secret to them. So all right, and the reason that we only add them to the queue if they don't have the secret is, remember, if they already had the secret before, then they will already be in this scene set, so we don't have to worry about that. Anyway, that's all we do. So we process the entire queue to kind of BFS our graph in this time iteration, and then we continue on forward. And remember, it has to proceed linearly for this to work, again, which is why we sorted the meetings in the beginning, so we have them in chronological order. So that's really it. At this point, if I don't mess up my indentation, all we have to do is return has secret, which will be the list of people who have the secret. Let me just run this so to make sure I didn't make any syntax errors or anything stupid. Yep, there we go. Apparently English is not my first language, despite growing up in the United States and living there for the past 25 years. But anyway, let's see. Okay, cool. So we haven't made any stupid bugs. Let us submit this. And we can see once these test cases run, hopefully I don't get a TLE here. Okay, cool, it works. Great. All right, so what is the runtime complexity on this one? So obviously we do a sort here, and sorts are going to be, n log n. So we have an n log n here for the sort. Building this meeting dictionary is going to be big O of n, because obviously we just have to process the meetings. So we're going to have an extra big O of n here. And then we have to actually do this part for actually processing the has secrets. So this part is tricky. It looks like we have a lot of nested things here, but remember that we can prune our graph based on who has already seen the secret. So I think in the worst case, we'll go through everyone at once. I think in the worst case, that first meeting, whatever, first comes out of this iteration here, we'll have everyone connected and we need to traverse the graph entirely in that worst case. But after that, because everyone has the secret at that point, we'll actually never do anything inside of our queue traversal here, our BFS here, which means that I think in the worst case, this entire thing here is going to be big O of n, because we're only going to have to traverse all the nodes in the graph once, right? Once someone has the secret, then we really don't have to traverse anymore after that. So in that worst case where everyone gets it, I believe it should be that you just get it on the first iteration through here, but I could be mistaken. I want to say that it's big O of n. It could be n squared. I'm not entirely sure, but from other comments on Leetcode, I think it's big O of n because we do prune the search. All right, obviously, people who already have the secret, they're not actually added to the queue, so we won't actually have to do any processing there. So I'm going to say that our runtime complexity is going to be, just dominated by this n log n here, and that's going to be the actual runtime complexity. In terms of the space complexity, obviously to do a sort like this in place costs big O of n time, space, and then building the meeting dictionary, that's also going to be big O of n. Storing the has secret, in the worst case, everyone's going to have it. So that means it's also big O of n. And then obviously our queue for the graph, the graph and the queue here, again, it's just going to be storing all of the elements. So I think it's just going to be big O of n for the space. I keep saying time. So I think, don't quote me on this one, I'm not entirely sure, but my best estimate would be that your time complexity here is going to be big O of n log n. Although it could potentially be, in the worst case, I think, big O of n squared. I'm not entirely sure. Please, someone in the comments, if you're 200 IQ, please let me know if I'm wrong here, but I do think it's big O of n log n, and then space complexity wise should be big O of n. So that is how you solve find all people with secret. At least we know for sure that this solution works. In terms of whether or not it's the most optimal, I'm not sure. This is a solution that does work. Obviously, you can see it is accepted by Leetcode, and it does pretty well. I think even my first one, which had the same code, did a little bit better. It was like 70%. So it's not like we're scraping the bottom of the barrel with the solution. I think it's pretty good. I think it's most likely the optimal solution here. So that's how you solve it. I'm going to stop rambling here because this video has probably been 20 minutes. Anyway, if you enjoyed this video, please leave a like and comment on the video. It tremendously helps with the YouTube algorithm and helps me reach a broader audience. And if you wouldn't mind, please subscribe to the channel. Again, the more subs I have, the more videos I can make for you guys, and the easier I can make it for you to get into FAANG, because solving a lot of these Leetcode questions ain't easy, and it's really nice to have these videos explaining them to you when you're absolutely stuck and you have no idea what to do. So, like, comment, subscribe. Thank you for watching, and I'll see you in the next video. Bye.